Okay, virtual day 35, May 6th. We're going to look at the two different types of sequences, arithmetic and geometric. It's two separate sections, but they're both relatively short, so just bear with me. Arithmetic means that you add something each time. Arithmetic, addition, I hope that is easy for you to remember. B is going to be what's called your common difference, which is what you're adding each time. And this whole formula here is your recursive formula. That means that it uses the term before, so it uses the previous term to find the next term. So you have to have the term before it in order to find the term that you're looking for. So is this arithmetic? You can tell if it's arithmetic just by looking to see the difference between each one. It's called the common difference. So from 4 to 7, you're adding 3. 7 to 10, you're adding 3. 10 to 13, you're adding 3. So this is arithmetic. Our common difference is going to be 3. And our recursive formula for this equation is a sub n. So what the nth term that you're looking for is equal to a sub n minus 1, which is the term before it, and then plus your common difference, which is 3. This one, when you have a linear equation as your sequence, it's always going to be arithmetic. I'm going to show you this by finding our terms in our sequence. So for n equals 1, 3 times 1 is 3, plus 5 is 8. N equals 2, 3 times 2 is 6, plus 5 is 11. N equals 3, 3 times 3 is 9, plus 5 is 14. I'm going to do one more. N equals 4, 4 times 3 is 12, plus 5 is 17. So the easiest way, outside of knowing that a linear equation is arithmetic, is by looking for your common difference here. You're adding 3 there, you're adding 3 there, you're adding 3 there. If you keep looking, you're going to keep adding 3. So my common difference is 3, and this is arithmetic. This equation is your explicit formula. A recursive formula uses the a sub n minus 1, or the term before it. The explicit formula means that you can use any n you want. You can find any term just by knowing the number term you want to find. And you don't have to have the term before it. Here, again, this is linear. So I'm just gonna show you finding the first 4 terms and then looking at it that way. So if n is 1, 4 minus 1 is 3. If n is 2, 4 minus 2 is 2. N is 3, 4 minus 3 is 1. N is 4, 4 minus 4 is 0. Each time you're subtracting 1 in between. So my common difference is -1, which means it is arithmetic. Again, this is an explicit formula. The nth term of an arithmetic sequence, this is how to find the explicit formula given the first term and the common difference. So again, explicit means you can find any term without having to know the term before it. A is always going to be your first term. N is the number term that you're looking for, and B is your common difference. And N is your term number. Again, explicit formula can use to find any term. Recursive formula has to use the term before. So here, if I'm the 13th term of this sequence, you have to find your first term, your common difference, plug it into your formula, and then plug in 13 for n. So this is our n value. This is our a value, which is 2. So a is 2. And our common difference d, we're adding 4. Adding 4, adding 4, adding 4, it works. So d equals 4. So I'm going to plug this in. I'm going to find my equation. A sub n equals a, which is 2, plus n minus 1 times d, which is my common difference of 4. And I'm going to simplify this equation. When you distribute here, you get 4n. 4 times negative 1 is negative 4. 2 minus 4 is negative 2. And then I'm going to plug in 13 for n to find my 13th term. So a sub 13 is going to be 4 times 13 minus 2. 4 times 13 minus 2 is going to give you 50. So that means that my 50th or my 13th term is 50. I add 4 each time. When I start with 2, my 13th term is going to be 50. Now this one we're going to have to use some elimination to solve the equation. The 8th term is 75, the 20th term is 39. Find a and b. So if the 8th term, so that n equals 8, a sub n is 75. Here, if n is 20, then a sub n is 39. So I'm just going to set up this equation in the same way using this arithmetic sequence formula here, this explicit formula. So we have 75 equals, we don't know what our first term is, but we know what number term we're looking for. 8 minus 1 times, we don't know our common difference. Simplify that a little and you get 75 equals a plus 7d. Going to do the same thing for my 20th term. 539 equals a plus 20 minus 1d, or 39 equals a plus 19d. Now, if I am going to solve this is a system of equations, I'm going to write one on top of the other. So 75 equals a plus 7d, and 39 equals a plus 19d. The goal here, this is elimination, is to get one of your variables to cancel out. Since we have the same number of variables here, we can just multiply this whole equation, either one of them, by a negative, or we can subtract these equations and get our answer that way. So 75 minus 39 is 36. A minus a cancels. And 7 minus 19 is negative 12. So negative 12d. Then I have a one variable equation here, so I can solve that. Divide both sides by negative 12, and you get d equals negative 3. Then you're going to plug that back in to find your first term. So you can plug it into either one of the equations. I'm just going to plug it into the top one. So 75 equals a plus 7 times 3. 75 equals a minus 21, sorry. Add 21 and you get a equals 96. So our d, our common difference is negative 3. Our first term is 96. Almost done with arithmetic. The only other thing we need for arithmetic sequence is when we have the sum of n terms of an arithmetic sequence. You can use this in a calculator, but here is the formula. So find the sum of n terms of a sequence, and if it doesn't give you the number, it gives you a variable n terms, then you're just plugging in what you know and simplifying that. So n over 2, we don't know what n is. That's our n value. And then this is our sequence. A is your first term. So if you remember from your formula, you just plug in 1 for n. So your first term a equals a sub 1. So I'm plugging in a equals 1. 3 times 1 plus 5 is 8. So my first term is 8. I'm going to have n over 2 times a, which is my first term, plus a sub n, which we don't know. And that's all you can really do there. I'm just going to leave that guy like that. Now, if it gave you, said find the sum of 9 terms of the sequence, and you'd plug in 9 for n, and you would need to find the 9th term by plugging in 9 for this sequence. On your calculator, you're going to use the sum and the sequence key, or you can use the sigma. If you use sigma, you will start with k equals 1, and you're going to go up to whatever your term is here of 20, and n point 9.5 n plus 2.6. Sum of sequence is how I'm going to do it on my, because that's what my old calculator does. So again, you have to be in sequential mode. You're going to catalog, hit P because it's closer to the sum. Catalog S to get the sequence. And I want the sequence of my 9.5 plus 2.6, so that's my formula. For n from 1 to 20, because I want the first 20 list of 1. And I get 2,047. So if you added the first 20 terms together, that would be your sum. So that's arithmetic. Arithmetic is addition. Geometric is multiplication, where R is your common ratio, what you multiply each time. This, again, is your recursive formula, means it uses before. You have to have the term before. So is this sequence geometric? So geometric means I'm multiplying something each time. So 2 times what gives me 6? Well, I'm multiplying by 3. Does that work here? 6 times 3 is 18. 18 times 3, and this one's going to go in your head, is 54. 54 times 3 is 162. So this is geometric. My common ratio is 3. So I can say, if I want to go at the recursive formula, a sub n equals 3 times a sub n minus 1, which just means I'm multiplying each term by 3 to find the next term. This one, I'm going to plug in for n to get some terms here. At n equals 1, 2 to the negative first power is 1/2. Negative in the exponent, move it and lose it. It's kind of how that works. Makes it easier for you. N equals 2. That's 1 over 2 squared, or 1 over 4. Calculator 2. N equals 3. That's 1 over 2 cubed. Is that negative? So I'm just going to make a note. 2 to the negative. So 3 is going to be 1. 2 cubed is 8. N equals 4. It's going to be 1 over 16. And n equals 5 is going to be 1 over 32. So to get from each one to the next, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So I'm multiplying each one by 1/2 to get that for 1 to stay the same and for my denominator to be multiplied by 2. The common ratio here is 1/2. Same with this one. So basically an exponential equation is going to translate to a geometric sequence. So linear is arithmetic, exponential is geometric. So here n equals 1, 4 to the first power is 4. 4 squared is 16. 4 cubed is 64. 4 to the first power, 256. 4 to the fifth power, 1024. Now what am I doing each time? So 4 times 4 is 16. 16 times 4 is 64. Does that follow? So 4 times 4 is 64. I can't see what I'm doing there. 4 is 256. 1024. So yes, this is geometric, and our common ratio is 4. We're multiplying each one by 4. The one above was our recursive formula. For the nth term, this is our explicit formula. Where A is your first term, R is your common ratio. So to find the 9th term of this sequence, I have to write my equation and then plug in 9 for n. So my first term is 10. What am I doing each time? Well, to find what I'm doing each time, I'm going to take each term. So I'm going to take 10, and I'm going to multiply it by the ratio, and that's going to give me my next term, which is 9. So I can find that this way. So that means my common ratio is 9/10. Does that work? 9 times 9/10. So does 9 times 9 equal 81/10? Well, we multiply fractions, multiply straight across. 9 times 1 is 81. So that's kind of how you can figure out your common ratio, and you can check that if you'd like to keep going. So A sub n, this is my explicit formula. My first term times my common ratio, which is 9/10, to the n minus 1. That one is explicit. It asks you to write the recursive formula. So recursive is A sub n minus 1 times 9/10. So I'm multiplying each term by 9/10 to get the next term. So to find the 9th term of the sequence, I'm saying n equals 9. So here I either have to know the 8th term, or I can plug it into my explicit formula. So A sub 9 is going to equal 10 times 9/10 to the 9 minus 1, which is 10 times 9/10 to the 8th power. 10 times 9/10 to the 8th power. And you get this. It's just too big of a fraction, too big of a numerator or denominator for it to simplify to a fraction for you. I'm going to round that 4.30. Just a couple more. The sum of n terms of a geometric sequence is represented by this formula. So when you have a certain number of terms, you use this formula A is your first term, and R is your common ratio, just like before. So this one is my sequence. N terms just means n is going to be a variable here. So my first term, I need to know what A sub 1 is. This is my explicit formula, by the way. I'm going to plug in 1 for n. So I have 1/2 for the first term, which is 1/2. So that's my first term. That's my A value. So S sub n is going to equal 1/2 times 1 minus what is my common ratio. So I'm going to find my next one, A sub 2. All right. A sub 2 is going to be 1/2 squared. You have to distribute that squared to both. 1 squared is 1, 2 squared is 4. A cubed, 1/2 cubed. 1 cubed is 1, cubed is 8. What am I doing each time? I'm multiplying my denominator by 2, so my common ratio is 1/2. So 1/2 to the n here, 1 minus 1/2 there. Then I'm just going to simplify as much as I can here. So I still have my 1/2 out front. Basically, all I can do here is simplify my denominator because my variable is an exponent. So 1 minus 1/2 to the n over 1/2. Well, I'm multiplying by 1/2 and dividing by 1/2. So S sub n is 1 minus 1/2 to the n. So the sum of n terms is this formula. On your calculator, the sum of the first 15 terms. So this would be n equals 15. Find it on your calculator. So you can use the sigma. If you use the sigma, and start k equals 1 to 15 of 1 to the n power, or yep, like that. And then that will give you your value if you use the summation notation. I'm going to use the sum sequence. Again, because my calculator does not have summation notation, so catalog sum, and then catalog s sequence. My formula is 1 to the n, 4 n from 1 to 15, step of 1. So I'm plugging in, starting at n equals 1, ending at n equals 15, going up by 1. So from 1 to 2 to 3 to 4. And you get this 0.49, right? Check, it doesn't simplify as a fraction because the numerator and denominator would probably be too big. The denominator. The difference between arithmetic and geometric series, you can find the sum of an infinite geometric series. That means there is no bound on n, as long as it is decreasing or your common ratio is less than 1. It means you are decreasing each time. Each term gets smaller and smaller by the same amount. So the sum here, so our first term is 2. We need to find our common ratio. So to find our common ratio, 2 times our ratio is equal to my next term. Divide both sides by 2. And you get 4/6, which is 2/3. So my common ratio is 2/3. So I can find my sum of my infinite series using this formula, which is equal to that. A, which is your first term, over 1 minus your common ratio. So my sum is going to be 2 over 1 minus my 2/3, which is 2 over 1/3 divided by 6. And then this last one, I really like this. I think it's awesome that this decimal equals 1. So this decimal, 0.9 repeating, equals 0.9, 0.09, plus 0.009, plus all the way, right? Now, what you're doing each time is dividing by 10. So your first term is 9/10. And if you're dividing by 10, that's the same thing as multiplying by 1/10. So 0.9, if you want to say 0.9, right, 0.09. So 0.009, so that's not pretty. So now I can plug this into my formula here. My first term is 9/10. Dividing that by 1 minus 1/10, which is 9/10 divided by 9/10. Anything divided by itself is 1, and I just think that's really cool. If you really go on forever, then 0.9 repeating is actually 1. Alright, so that is sequences. This was your last day of sequences. You have one more lesson, and then you are done with pre-cal. And that's on limits. It is not super hard. So work on this quiz for sequences and holler if you need me. Y'all take care.